Okay, good morning. I'm Bill Miller. I'm the CEO at XIO Technologies. Big data is great, right? The emergence of big data over the last few years has driven the incredible capabilities to derive insights and do some things with AI and machine intelligence that just really interesting topic. But there's some problems with big data and the way it's been instantiated over the last few years. It's a batch technique. So it's, give data scientists a big, large volume, high variety data set, let them run some analytics against it, they'll generate some insights, but it takes a while. So the problem with big data is the insights typically come slow and maybe too late for a lot of problems. More recently, there's been an emergence of let's call it fast data or streaming data, analytics on streaming data. This has been around for a while, but you've got a pipeline of new data coming in. You can do some analytics against it. The problem with fast data analytics is the data set's too small to do some really interesting things against it to generate interesting insights. Basically the data set size is what can fit in memory. A lot of this is in-memory analytics. You have to fit it in memory. You go outside of memory, these techniques don't work. So the math ends up being pretty simple things. Excursions from a distribution, for example. What we really need is big, fast data. And certainly the industry is headed in this direction. So how do we get very large data sets that include the recent data that is just coming in, added to that data set, and generate real-time responses, get real-time insights that can allow us to operationalize big data. So it's this problem of making big data fast that Xelio is targeted at. So we think of Xelio as an edge computing solution. Edge computing is getting talked about a lot now. People mean a lot of different things by edge computing, everything from doing interesting thing with data that comes off the Nest on your wall. Obviously, the amount of data you're going to get in that scenario, you might aggregate it up to a lot of data, but a lot of stuff is done in lightweight computing. We think about edge computing problems as the big data, high velocity data edge. So the attributes we targeted Xelio at are high velocity data, high volumes of data, big data kinds of problems, real-time complex analytics being applied to them to get real-time answers. And when you have that situation, when you have very large, high-rate data creation, you need to do the computing where the data is created. So we don't always think about edge computing as a geographic idea. That's certainly the first thing that comes to mind when people hear edge computing. We think about it wherever the data creation rate that has to be ingested, computed against with algorithms that require a pretty large working set of big data analytics kinds of problems and real-time responses happen. Sometimes that can even be in the middle of the data center. You just don't
see
have
a lot of
time
places which require 30 gigabytes per second at the edge. I mean,
there are places that require 30 gigabytes per second at the edge. And specifically,
and petabytes of local storage-ish kind of numbers?
Cybersecurity,
I can
defense and intelligence.
I can see where we started looking
Trading
at
surveillance.
Massive sources where you need real-time analytics as well. It's easy to, well, not easy, but it's easy to do one or the other, but it's harder to do both at the same time.
Exactly.
Smart city stuff, I imagine, must be
Harder
collecting
to
live data.
impossible.
A lot of people talk about these kinds of edge computing problems in the Internet of Things, smart cities you brought up. I think that's true. That's not where we're seeing the near-term use cases for this. Literally, these three markets, these three kind of market areas are where we're really seeing near-term demand for this kind of very large working set, complex mathematics against it to get real-time insights. Well, there's high velocity streaming data coming in that's being added to the set. There are a few things outside of these three spaces, but this is where we're doing a lot of our work
science, high performance computing kinds of things, maybe.
Yeah, life sciences, because a lot of them are research kinds of things. This is where you want to operationalize big data.
Right.
And where do you want to operate? Life sciences isn't quite there yet. I can see it in the future, right? Where you're actually maybe doing real-time genome analysis on a patient and trying to generate something real time, but it's not today. Internet of Things, not so much today, but these spaces, there are heavy needs for this today, operationalizing big data. A lot of these use cases have this pipeline. right? So it's an input data stream or multiple, that maybe being enhanced with other data streams. It's time series data. It has to be time correlated. You have a working set. You're doing real-time big data analytics against it. You might also put data out the back end, either all of the data, the raw data, or filtered data that go out to a cloud instance to run machine intelligence against it, to train algorithms back, for example. And this is very much like the pipeline you might see in a lot of in-memory streaming analytics kinds of use cases today. But the big difference is, again, if I'm doing it in memory, I don't have a high volume data set to work against. And a lot of the best big data analytics methods, AI machine learning methods, work better if you have a larger, higher variety data set. So these are the kinds of use cases. And I'm going to go through some examples of things that we're working on now, mostly with partners. SolarFlare is a company we've done some things together with. They have a system called Solar Capture System. This is a packet capture system. This will allow you to capture, for example, 4x10s or 40 gigabit per second, tap a network, grab all the packets, all of them, store them without loss into a working data set on the back end so that you can run analytics against it as the data stream's coming in. So you gotta remember, this is a hard problem. I'm running a data stream in, having to store it very high velocity without any loss. I need to actually access that data set simultaneously to run analytics against it if I'm going to do real-time analytics. That is not a problem that an off-the-shelf architecture previously could do. We're going to talk about how we can. I'm going to leave that for Gus, but packet capture and analytics is being used in cybersecurity to look for zero-day threat, anomaly detection, looking for groupings in network traffic that look unusual. These are algorithms like k-means to look for clusters. It's used in trading surveillance. So this in an algorithmic trading world, if something goes wrong, it can go very wrong very fast. So you might want to watch all the market data as it streams by. You don't have time to actually use message streams. You actually take packet streams. You look for clusters of unusual activity in those streams, and you want to react to them fast. You can imagine the kinds of things the intelligence community, the defense community might do with this, things that either we don't know or we can't talk about. But that's another partner that we've worked on in the financial market trading analytics space is Kx. Kx is the leader in time series database. So they have special method of storing data on the back end to capture time series data. We've actually worked with Kx to do some benchmarking. There's the Securities Technology Analysis Center, STAC, is an industry benchmarking group for the trading surveillance and algorithmic trading world. And we've worked with Kx on putting a STAC M3 benchmark, which is currently in their vault. So if people are members of the STAC group, they can go in and see the benchmark results. We're actually going through the audit with STAC now, which will allow us to make these results public. The interesting thing about these results, and again, we'll talk about the Excelio system specifically in its architecture. It is a 2U box. It includes compute and storage in the box. We are outperforming STAC benchmarks, the STAC M3 benchmarks, for systems that take a full rack or a couple of racks to deploy. And when you're trying to capture market data in the POP where the exchange lives, that's expensive real estate. So taking 2 racks to 2U is a pretty good value proposition. Another partner, Asculta, is a company that provides cybersecurity solutions, mostly to the U.S. government, some other governments, both defense, intelligence, and civilian agencies. They're using our platform to develop systems to do anomaly detection and rapid response, again, to look for zero-day threats. Again, it's mostly a packet analysis kind of proposition. Vion is a large systems integrator to the government. They're doing data fusion solutions, mostly for the intelligence community, but also for real-time business intelligence kinds of things that are deployed in defense and government agencies. And Isaac is a company that is actually doing predictive and prescriptive analytics based on very large graphs. So this is multiple input data source, very large graph analytics, and they're trying to move their analytics from, again, sort of a batch mode to more of a mode that can take new data into that graph. So they're having to rebuild a very large graph with each new piece of data coming in. Graph builds for them were taking hours to days to build the graph before they could run analysis against it. They're trying to get that for a government customer. They also actually have customers in healthcare and utilities, grid network kinds of distribution problems, but they're trying to get graph rebuilds with new data to happen in seconds or minutes rather than hours or days.
So you see Accelero actually being sold by these partners, effectively, to their various customers.
And we're still, you got to remember, Accelero is still a very new product. So a lot of these things are still in development.
Right.
There will be partners of ours that will take Accelero to market with their software, with their solutions, their services, probably branded by them.
Right.
There will also be cases where they'll act as integrators,
Okay.
where we'll sell with them or meet in the channel kinds of strategies. So all of those are possible.
Right.
I think, as Gavin noted, the one thing we're really not going to put a lot of effort in is to sell the Accelero system as a platform to end users to build their own system on top of. It's mostly going to be through partners. I think very large enterprise end users in some cases will certainly want to take the Accelero system and build their own solutions on top of it, but a lot of it is partner market.
The idea there is to give that analytic market the tools they need to have a back-end storage system that can really respond, that they don't have the tools to build it.
And again, this is compute plus storage in this case, right, in an integrated package. And a lot of these edge applications, it works better to use an appliance-like solution. I mean, they don't have the same kinds of separate scalability problems or scale-out problems that you might find in a big data center. They're looking to put some software on an appliance that hook it up to a network or an input message data stream and run analytics there. So that's what this is intended for.
Is Accelero NEBS compliant and all that stuff? I mean, does it support?
We're working. We have a lot of requests. There are a lot of requests in the government world for certain compliance around it. There will be some things. I think there are some opportunities in telecommunications where there's some things like that will have to be done. A lot of that stuff is still being mapped out, prioritized, and working through but we're headed in the direction. And again, often working with a solutions partner, an integrator or a software partner in the space to get through those compliance issues. This is another example from industrial Internet of Things. Everybody has to have an IoT example today, right? Here's my IoT example. This is early, but there's a utility company that is doing a pretty large-scale experiment with smart grid. And you can think about, in a world where you have clean energy that is not necessarily like a base load, right? It comes and goes, and how do you do grid and generation optimization, and can you outfit your grid with sensors, especially with industrial users? And then it turns out the data collection problem around this and the analytics problem is a pretty big one. So our platform provided, and we're doing this with a partner, a good opportunity for that. So, we threw some logos up here. People we're working with or software we're working with to package solutions onto the platform, just to kind of give you a few examples. There are a lot more conversations than this going on. There's a lot of, if you think about these kind of real-time pipelines, things like open source software from Apache, like Kafka and Storm, are often integrated into parts of these solutions. And there's some interesting companies out there that we've begun to work with, like LeviX. LeviX has a key value store that is optimized to run in NVMe flash storage. They were working on that independent of us. We kind of found each other, and we've done some benchmarking with LeviX. So you can think about an in-memory streaming data analytics pipeline that might use Kafka on the front end, maybe Storm to do some data transformation, maybe today using Spark to do in-memory analytics, and then maybe sits on top of Cassandra, right? So you can lift that out and stick LeviX in instead of Cassandra, which is optimized to run on a platform, and get tremendously better performance out of that kind of a streaming pipeline.